In this video, we're going to learn how to derive the work done equation and heat supplied equation in an isothermal process. Now, let's consider the non-flow energy equation, which states that heat supplied is equal to the internal energy plus work done. This is also from first law of thermodynamic, considering a non-flow process. So let's call this equation 1. Now, if we differentiate this, the Q is going to be equal to du plus dw. Let's call this equation 2. Now, you recall internal energy itself is a function of temperature. So this means if we differentiate internal energy, we are going to have Cv dt. And this is obviously going to be Cv into T2 minus T1. So for a constant temperature process, this simply implies that T2 is equal to T1. Therefore, the U is going to be equal to 0 for a constant temperature process. So if that's the case, this simply now implies that the Q, being the heat supplied, is going to be equal to what? Just the W. So whatever we get for the work done is going to be the same thing as the heat. So let's call this equation 3, which is our basic equation. Now recall that in thermodynamics, work done is actually the product of P, pressure times volume, right? And mathematically or as well is given as an integral from V1 to V2 of P dV. So let's keep this equation, call this equation 4, sorry, equation 5. Okay, 4 is correct. Call this equation 4. Now from the equation of state, okay, we have P1 V1 all over T1 to be equal to P2 V2 all over T2. So if since we are considering an isothermal process, recall, for an isothermal process, T1 is equal to what? T2. So which means the temperatures are equal, so they cancel out. This simply implies that this automatically turns into a Boyle's law. P1 V1 equals P2 V2, and you have this. So this can actually be written simply as what? PV. Let's call this equation 5. Now from 5, let's make pressure subject of the formula. If we do that, we are going to have P to be equal to simply P1 V1 all over V, and this is also going to be equal to P2 V2 all over V, simply making pressure subject. So you divide both sides by V. Now this is our pressure, this is our work equation. We simply plug this pressure in place of the pressure here for the work equation, right? So recall, work done is equal to integral V1 V2 P dV. So this is going to be equal to integral V1 V2 P. You can choose any of these, or you can work with them alongside, right? So I'll work with them alongside. So we have, in place of P, this is now going to be P1 V1 all over V dV, and this is also equal to integral V1 V2. In place of P once again, we're now placing P2 V2 all over V dV. Now P1 V1, P2 V2 are known values of pressure and volume, so they are actually constant values. You pull them out of the integral sign. So our work done becomes P1 V1 integral from V1 V2. So I'm left with dV over V for the first case. Second case still remains P2 V2 integral from V1 V2, also dV all over V. So work done is now going to be equal to P1 V1. So if I integrate dV over V, or simply integrate 1 over V, I'm going to have lane V from V1 to V2, Same thing here. This is now P2 V2 lane V from V1 to V2. So we have this. Now let's plug in the limit of integration into the integral. We are going to have that work done is now equal to P1 V1 into, remember, upper limit minus lower limit, so that becomes lane V2 minus lane V1, same as P2 V2 lane V2 minus lane V1. So let me take this off. Okay, minus lane V1, and we have this. So remember from the laws of logarithm, when you have two logs subtracting one another, it simply means one of the log and then dividing their numbers, right? So this is now going to be work done equals P1 V1. So we have this now to be lane V2 all over V1. So simply take one of the log and divide their numbers. And this is going to be equal to P2 V2, same thing, lane V2 all over V1. So this is the first equation for work done under an isothermal process. That's the first equation. So if you're given a question and you know the initial values of pressure and volume, you can simply plug that into this equation and find the work done. Remember, for an isothermal process, the heat supplied is equal to the work done. So this equation also is valid for the heat supplied. Now, also recall again from equation of state. Recall again that from equation of state, you also have that PV itself is actually equal to RT, where R is universal gas constant. So this means from here I can simply make this simply implies from here that P1 V1 pressure and volume changes with respect to temperature. R there is kept constant. So P1 V1 is going to be equal to RT1. Similarly, P2 V2 is going to be equal to RT2. So you simply, in place of P1 V1 in this work done equation, simply plug in the value as RT1 and then RT2. So we have a new work equation. So we have a new work equation. W is now going to be equal to P1 V1 is RT1. So you have RT1 lane V2 over V1. This is also equal to P2 V2 is RT2 lane V2 over V1. So this is the second equation for work done for an isothermal process or in an isothermal process. And these equations are valid, recall, for heat. They are all valid for heat. Heat supplied is equal to the work. So these two equations, call this, this is equation 6 and this is equation 7. So these two equations are valid for both work and heat supplied in an isothermal process. Alright, so these are the two basic equations we've gotten for work done in an isothermal process. One more thing, you recall, we said earlier that from the equation of state, we had that P1 V1 equals P2 V2. So from here, we can actually find this ratio V2 all over V1. So if we divide here by V1, if we divide here by P2 V1 over P2 V1, so see, V1 cancels V1 here. We have P1 over P2. This is going to be equal to P2 cancels out here. We have V2 over V1. So which means this ratio V2 over V1 can also be represented as what? P1 over P2. So if you plug that into these equations, then we are going to have another equation for the work done to be equal to, for the first case, P1 V1 lane. In place of V2 over V1, we have P1 over P2, and this is also equal to P2 V2 lane. In place of V2 over V1, we have P1 over P2. So you can call this equation 8. Similarly, work done is equal to, for this case, you have RT1 lane, in place of V2 over V1, you have P1 over P2. Also, this RT2 lane, P1 over P2. That's equation 9. Okay, so these are the equations for the work done in an isothermal process. So if you're given the initial volume and the initial pressure, once your parameters here are complete, then you can use any of the equations to solve. If you're actually given initial temperature and final temperature and initial and final volumes, it means you can use this equation to solve. If you're given initial temperature and pressure and final temperature and pressure, it means you can use equation 9 to solve. And remember, earlier we said that heat supplied is equal to the work done. So which means these four equations 6 to 9, right? 6, 7, 8, 9, yeah. Equation 6 to 9 can be used for work. It can also be used for the heat supplied on the system. Alright guys, so that's how to derive the isothermal process, work done and heat supplied in thermodynamics. I will see you in the next video. Cheers.